In this video lecture, we're going to discuss Boolean algebra. Specifically, we're going to discuss introduction about it, basic operations in Boolean algebra, Boolean expression and truth tables, simplification theorems, standard form and canonical form of Boolean equation, and complementing Boolean expressions. So our objective in studying Boolean algebra is, or are, understand the basic operation and law of Boolean algebra, and relate this operation and law to circuit composed of AND, OR, inverters, and switches. And also, we're going to use laws and truth table to prove a certain algebra equation. And also, we're going to use Boolean algebra to manipulate our expression to obtain sum of product, product of sum, simplify the expression, or find complement of the given expression. Okay, so in Boolean algebra, in discussing Boolean algebra, we're going to refer to a switching device, which accept two status, or as or we call it a two-state devices. So for the input, we're going to use variables, Boolean variables like x or y, and another variable that represent our output. And usually, we are going to use 0 and 1 to represent the two status. It has no value, numerical value is 0 and 1 just represent the two states. So for example, if we are referring to logic gate, 0 represent a low voltage, while 1 represent high voltage. In a switching circuit, 0 represent an open switch, while 1 it represent a closed switch. Okay, so the basic operations that we're going to discuss in Boolean algebra are AND, OR, and complement, or sometimes we call it inverse, or sometimes we call it NOT gate. So we have AND, OR, NOT. And also, we're going to discuss what is the meaning of 0 and 1 in switch. So if it's open, it means it's 0. If it's 1, the switch is closed. And also in our switching circuit, we have the NC and NO. If say NC, it's normally closed. Okay, this is an example of NC. While normally open, or NO, usually it's open. Okay, if variable x represent NO, therefore x prime represent NC. So they complement each other. NO complement NC, NC complement NO. Okay, so let's discuss the first operation, which is NOT. So complement, inversion, NOT. So we usually use prime to denote complement. We write the prime after the variable, after the value. So for example, 0 prime, it means 1. 1 prime means 0. Okay, so it invert the value from 0 to 1 or 1 to 0. And we also use prime for if we're referring to the input variable, for example, x. So x prime is equal to 1. So therefore, the original value of x is 0. If x prime is 0, therefore x is equal to 1. Okay? So it inverts the value, the input. And this is the symbol for NOT gate, rather. Okay? So we have a triangle with a circle. So x input, then the result is x prime. Second operation, AND operation. So in AND operation, it's like we have a two series switch, wherein if one of the switch is open, we're going to have an open circuit. The only time that we're going to have a closed circuit if both switch are closed. That's why the truth table, in the truth table, okay, shows that if the input are both 1, the output is 1. But if there is 0, it means open, the output is 0. Okay? And this is the symbol for AND. So input AB, result AB. By the way, the symbol to be used for AND is the same as multiplication. So a dot, a parenthesis, or no symbol at all. Okay? And third operation, OR. It is synonymous to addition of binary. Okay? As long as there is a one input, okay, an input which has a value of 1, the output is 1. So 0, 0, 0, 0, 1, 1, 0, 1, 1 will yield an output of 1. And also, OR operation is synonymous to a parallel switch, wherein at least one of the switch is closed, we're going to have a closed circuit. Okay? And the symbol to be used for OR in our circuit, this is the symbol for it. And for the R equation, we're going to use plus sign to refer for OR. Okay? And combination of this and or not will give us a complex circuit. Okay, so for example, we have A, B not plus C. Okay, so logical diagram of A, B not C is basically A, B not is ANDed, but B is negated. So before we input B to AND, it should be negated first by a NOT operator. Okay, and then it is ORed with C. So A ANDed to B not or to C. So this is the symbol for the first equation. While for the second equation, A ANDed to C plus D not complement plus BE. So let's start with C plus D. So C plus D is basically C or D. And then ANDed with A. And whatever the result of this will be complemented. So that's why we have not here. Or to and of BE. So we have and here or together with this part of the equation. So that's how we create the drawing of the given circuit. Okay? And for the truth table, it gives us an idea what will be the possible output based on the given input. Okay? So in the input, we need to get all the possible combinations so that we could determine all possible output. So if we have 2 inputs, it means we have 4 patterns. So therefore 4 output. Okay? So the formula to determine the number of patterns is 2 raised to n, wherein n is the number of input. Okay? And each gate should have a column in our truth table to determine what will be the output. So since we have not here, we should have a column for A, not, and we have an OR, therefore we need to have a column for OR here. Okay, so that's our truth table. And another example of truth table, it could show us if the given equation are equivalent or not. Okay, so for example, we have AB not plus C is equal to A plus C and to B not plus C. So let's create a truth table for this equation first. So we have B not here, and then ANDed to A. So we have this column, and then OR to C. So this is the result for the left side of our equation, of our equality. And then right side, A plus C. For this column will represent A plus C. B not plus C for this column. And then under these 2 columns, we have this result. And as you can see, This column is the same as this column. Therefore, they are equal. So again, truth table can be used in verifying if two equations are equivalent. Okay? And also, truth table will give us an idea what will be the possible result based on a given input. Okay? So next meeting or next video lecture, we're going to discuss postulate and theorem that we're going to use for simplifying our Boolean equation. Thank you for listening. See you on the next video lecture.